At this point, when you look at the law of cosines, you're probably a little confused about that formula. So I'd like to go through this and just keep explaining again and again how the formula is derived, how it's created, and then eventually it'll just start to click. Let's start with just a random set of letters. Let's say we have a triangle A, B, C. This triangle can lead to three different laws of cosines. If you are working and you're trying to find side A, which would be known as little a, and you have little b and little c. So you know these two values, but you don't know side little a. You could simply say this: a squared, notice I'm writing in little values, is equal to b squared plus c squared minus, and it's going to be twice the product of the known sides, so it'll be 2 times little b times little c, and then you simply say times cosine of that angle, which would be big A. In this same triangle, different scenario, we've got triangle ABC. Maybe I have little a and I have little c, but I'm interested in finding little b. Since I'm interested in finding little b, and I would have to be given angle b, I would simply do this. B squared is equal to, now it's just going to be the other two sides, so I say a squared plus c squared minus, it's always the product of those two known sides, 2ac cosine big B. I'm not a fan of memorizing 500 different formulas. I would rather you all understand this process, how that formula is being generated. Because if you understand it for one, then it doesn't matter what you call the triangle, you can generate whatever you need. I'll finish this one up. We'll do a third one here. I've got triangle ABC. First time I didn't have A, second time I didn't have B, this time I don't have side C. So now I have little a, little b, but I'd have to know angle C. And so I'm simply going to say, since I'm looking for side C, little c squared equals little a squared plus little b squared minus 2 times, it's always these two sides that you're working with, those known sides, a, b, and then you go cosine angle C. Again, you can do this with x's, y's, z's, a, b, c, d, e, f, whatever the triangle is called. I'll do one more real quick example here. I'm not going to do the full-blown triangle. Let's say that I had triangle D, E, F, and you had side D and side F. You needed E. Since you're looking for side E, you need angle E, you would say little e squared is equal to little d squared plus little f squared minus 2 times d times f cosine angle E. And again, notice how I'm using the lowercase letters to denote my sides, capital letters for my angles. And that's how you would set up your law of cosines. In the next several examples, what I'll do is more specific problems so you can see how this is being used. Okay? And so this is the law of cosines. This is the structure for the law of cosines. Not really any examples on this. Okay? So that's our structure. I'll even call it structure. Oh, it'd help if I could spell. Structure for law of cosines. The structure for the law of cosines.